So along with factoring or solving using square roots or using our completing the square technique, we can also solve quadratic equations like this using the quadratic formula. So hopefully we know that there's a way that we can sing this. I will not torture you with this, but the idea is we've got x equals negative b and then plus or minus the square root of b squared minus 4ac all over 2a, where those a's, b's, and c's are the coefficients from our standard form equation of a parabola, of a quadratic function. And so it's not just out of nowhere that we get this formula here. It's actually the result of taking our completing the square process and applying it to an equation that doesn't have any numbers plugged in, but instead has a, b, and c in those respective locations in the equation. And then if you go through that entire process, you end up with this formula. And so we can now use this along with these other three approaches as a means for solving a quadratic equation. So that's what we'll work on here. So to start off with, I should make sure that I identify what those coefficients are so that I can plug them in correctly into my formula. So a is the number that's multiplying the x squared, so that's going to be 1. b is the number that's multiplying the x, so that's negative 5. And then c is that last number, so in this case that's going to be negative 6. And so those are just the values that I'm going to plug into my quadratic formula here. So we've got x equals, get things set up here. So it starts off right away with negative b, but I've got b as a negative number already, so a negative negative 5 becomes positive 5. Let's try to make that look like a 5. There we go. Then we've got plus or minus the square root of, now I've got to take b squared, so it's going to be negative 5 squared, and then minus 4 times a, which is 1, times c, which in this case is negative 6. And then all of that is over 2 times a, or 2 times 1. So now I just have to work on some simplifying here. So we've got x equals, so I still have this 5 plus or minus the square root of, now negative 5 squared is going to give me positive 25. Negative 5 times negative 5 is 25. And then on the back end here, I've got negative 4 times 1 times negative 6. So I'm going to get a positive, since I have a negative times a negative. And then 4 times 1 times 6 gives me 24. And then that's all over 2. So x equals 5 plus or minus the square root of, now 25 plus 24 is going to give me 49. I'll scroll down a little bit here to give myself some more room. And then this is, again, still all over 2. So now 49 is a perfect square, so I can take the square root of that. And so I've got x equals 5 plus or minus 7 all over 2. Now, in this case, I can go ahead and finish things out and actually get integer values by performing the operations that I have here. So I've got 5 plus 7, which is going to give me 12, and then I divide that by 2. So I've got 12 divided by 2, which equals 6. And then I've got 5 minus 7, so 5 minus 7 is negative 2, but I still have to divide that by 2, and so I get negative 1 as my second answer. So this is how we can use the quadratic formula to solve, just like we could by factoring if it's possible, as this one would have been, or by using square roots if it's set up that way, or by using completing the square as well. So for the second one, before we can start identifying what the values of a, b, and c are, the coefficients that we're going to use in our formula, we have to make sure that the equation is set equal to 0. So I have to add 1 to both sides to make sure that I get the correct positive and negative signs of all of my coefficients that I'm going to use. So that means my equation is going to be 2x squared plus 3x and then plus 1 equals 0. If I left that 1 on the other side as a negative 1 and used that as my c value, I would get an incorrect result by using the quadratic formula. But once I've done this, I've got x equals, get myself set up here, So once again, I've got a is going to be the coefficient in front of the x squared, so that's 2. B is going to be the coefficient in front of x, so that's 3. And then c is that number being added or subtracted on the back end, so that's 1. So we got x equals negative b, so again, referring to my quadratic formula up here. So if b is 3, then negative b is going to be negative 3, plus or minus the square root of, extend things here a little bit, so b squared, so that's going to be 3 squared, minus 4 times a, which in this case is 2, times c, which is 1, and then that's all over 2 times a, so 2 times 2. So in the numerator here, we still have this negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 2 times 1, so we get 8 all over 4. So 9 minus 8 equals 1, so I can get that far. So negative 3 plus or minus the square root of 1 all over 4. And so of course the square root of 1 is 1, so I've got x equals negative 3 plus or minus 1 all over 4. And now I'm in the same place that I was in the last one. So I've got x equals negative 3 plus 1 is going to give me negative 2, and then that's being divided by 4. So one of my answers is going to be negative a half. And then I've got negative 3 minus 1, which is negative 4, and then that still needs to be divided by 4, so I get negative 1. So my two answers in this case are negative 1/2 and negative 1.